Greetings, viewer. I am incredibly glad to see you on our channel. I hope everything is going well for you. And now, to the story. The Eastern Front turned into a nightmare for the German army. Soviet minefields stopped entire divisions. Tanks were blown up and offensives choked. The German command urgently needed to do something, and two firms proposed two different solutions. Both looked like the offspring of engineering madness. Both promised to turn the tide on the Eastern Front. But this story began with a simple problem. June 22, 1941. German troops burst into Soviet territory. Plan Barbarossa was designed for a blitzkrieg, a lightning war, featuring fast, deep breakthroughs by tank groups, the encirclement of Soviet armies, and the defeat of the USSR within 4 to 5 months before the onset of winter. But already, in the first days of the offensive, the Wehrmacht encountered something it did not expect. The Red Army was employing minefields on a scale unseen in European campaigns. Throughout the entire Great Patriotic War, Soviet troops used more than 70 million mines, about 30 million of which were anti-tank mines. Minefields were placed along all directions of the Wehrmacht's advance, from the Baltics to the Black Sea. Every such field turned into a deadly trap. For a blitzkrieg, speed is critical. Tank wedges must break through deep into the defense for hundreds of kilometers, giving the enemy no time to recover. But a minefield stops this frantic pace. A blown-up tank blocks the road, and the column stands still. While engineering units clear a path, Soviet troops manage to bring up reserves or retreat to new lines. Every delay in a minefield cost the Wehrmacht precious time. By the end of 1941, it became clear the blitzkrieg had failed. They failed to take Moscow. One of the reasons was precisely the massive use of mines. Mine clearing with probes and mine detectors was slow. It took hours and days. One missed high-explosive charge meant a blown-up tank. One anti-personnel mine meant a dead sapper. The German command needed a machine that could clear paths quickly. At the end of 1941, the Weapons Office issued a technical specification. The firms Alket, Krupp, and Mercedes-Benz were brought in for development. The requirements were specific. An armored self-propelled machine for mine clearing, a weight of no more than 40 tons, a length of up to 10 meters. The width of the cleared strip was to be 3 meters. The machine had to protect the crew from mine explosions and enemy fire. The firm Alket from Berlin decided to solve the problem radically. They created a machine on 3 giant wheels that was meant to simply crush mines with its weight. The engineers at Alket looked at the technical specifications and threw the tank-building textbook in the trash. No tracks, no complex systems. Just 3 huge wheels that had to be so powerful they would simply crush any mine encountered on the path. The idea sounded radical, but the firm had already begun to manifest it in metal. By August 1942, a finished prototype stood in the Alket workshops near Berlin. The machine received the designation VSKFZ 617, registration number NK101, factory number 9537, and it looked like the offspring of engineering madness. Length 6.28 meters, width 3.22 meters, height 2.90 meters, and most importantly, a weight of 50 tons, a full 10 tons more than the technical specification required. The Germans created a monster that exceeded all limitations. The heart of the design was the 3 wheels. 2 front wheels were the drive wheels, powered by the engine, and 1 rear wheel was swiveling for steering. The diameter of the front wheels was 2.5 meters. That is the height of an average apartment ceiling. Imagining such a wheel next to you is not easy, but the most unusual thing was not the wheels themselves, but their construction. A hinge chain of massive steel shoes is fitted onto the rim of each wheel. Outwardly, it looks like a bicycle chain, except each link weighs many kilograms. Every shoe could be replaced right in the field if damaged. The Pedrail walking wheel system was a British invention from the beginning of the 20th century that the Germans decided to use for their minesweeper. At any given moment, 3 shoes from each wheel touch the ground. That makes 9 points of contact simultaneously. This creates a massive pressure area on the ground. A mine is guaranteed to explode under such weight. This was the core of the entire idea. The engine was a Maybach HL120, a 12-cylinder gasoline engine with a displacement of 11.9 liters and 300 horsepower, the very same engine that was put in the Panzer IV. Only here, it is installed across the hull in the rear of the machine. 2 cooling radiators are behind the engine, with air intakes on top of the hull and ventilation grills on the back. From there, hot air exits. The transmission is located in the middle of the machine. From it, shafts go to the front drive wheels. The 720-liter fuel tank is located above the rear wheel. The range is unknown, but with such weight and power, it was clearly modest. Crew protection was seriously considered. The bottom of the hull was double-layered. The lower armor plate was 40 millimeters thick, and the inner plate was another 20 millimeters. Between them was an air gap. This created a distance of about 1 meter from the ground to the driver's seat. When a mine explodes under the machine, the shock wave should dissipate. At least, that was the theory. Steering the machine was implemented unusually. The driver turns a steering wheel. Through a system of clutches and power takeoffs, the steering wheel activates worm shafts on both sides of the hull. The shafts rotate in opposite directions. One shaft winds up a chain, while the other releases it. The chains pass inside the hull and are attached to the rear wheel from both sides. When the driver turns the wheel to the left chain tightens and turns the rear wheel to the left. The system works like a winch, slowly but powerfully. No differential control for the front wheels was provided, only the rotation of the rear wheel. It is like a bicycle, but weighing 50 tons. Armament: a turret from a Panzer I, Model A or B. A small 2-man turret with 2 7.92 mm MG-34 machine guns. Ammunition capacity: 2,250 rounds. This was not for fighting tanks. It was for protection against enemy infantry who might try to approach the slowly crawling sweeper. The crew was at least 2 people. The driver sits on the left, looking through a narrow slit in the front armor. Before him is an indicator of the rear wheel's position so he understands where the machine will turn. The commander is on the right. He is also the gunner, operating the turret and firing. The hull armor protects against large-caliber machine guns, but only those. Any anti-tank gun would pierce this machine straight through. It is not a tank, it is a sweeper. Its main protection is the thick floor and the distance from the ground. The engineers at Alcat created a unique machine. Nothing like it existed in the world. 3 giant walking wheels, 50 tons of weight, armor from below like a heavy tank. All for one purpose: to crawl along a minefield and blow up mines with its weight. But competitors from Krupp looked at Alcat's creation and decided it was too small. They created a machine that exceeded all expectations in its scale of madness. The engineers at Krupp followed Alcat's work. They saw the 50-ton three-wheeled monster and decided it was not ambitious enough. If 50 tons were good, then 130 tons would be even better. In 1943, Krupp began developing their version of a minesweeper. The philosophy was simple: more weight, a wider clearing strip, and higher chances of success. Krupp created a machine that surpassed all expectations in its insane scope. It featured an articulated two-section construction. Two parts were connected by a hinge in the middle. Each section was essentially a separate, self-propelled machine. Each had its own engine, and each had its own pair of wheels. Together, they formed something incredible: 4 steel wheels with a diameter of 2.7 meters. The width of each wheel's rim was 53 centimeters. Additional shoes with rubber soles were fitted onto the wheels for damping. But the main feature was the wheels being on different track widths. The front wheels were wider than the rear wheels. This meant the machine cleared a path wider than its own hull. The length was more than 15 meters, 1.5 times the length of the original technical specification. The height was 4 meters, and the weight was 130 tons. This was more than 3 times the requirement. Krupp turned the technical specification into a mockery of common sense. Each section of the machine was equipped with its own Maybach HL90 engine, a 12-cylinder gasoline engine with a power of 360 horsepower each. That made a total of 720 horsepower for 130 tons of weight. The specific power was a little more than 5.5 horsepower per ton. For comparison, the T-34 tank had about 17 horsepower per ton. The maximum road speed was 25 kilometers per hour, and on rough terrain, 4 to 8 kilometers per hour. Mine clearing was supposed to be carried out at exactly these snail-like speeds, slowly and methodically, crushing mines with the monstrous weight of the steel wheels. Armor protected the hull from machine gun fire. The crew consisted of 8 people. There were 2 control stations, 1 in each section. The machine could be driven in both directions without turning around. One would simply switch control from the front post to the rear. 4 seats with springs and hydraulic shock absorbers were in each compartment. The crew had to withstand the shocks from mine explosions. The articulated design allowed the sections to tilt relative to each other by up to 22 degrees to the right or left. This made for a 44-degree maximum angle between sections. This was meant to ensure maneuverability on uneven terrain. Large wheels and a high ground clearance of more than a meter theoretically protected the crew from the blast wave. Construction dragged on. On June 4, 1943, representatives of the Weapons Office inspected the finished components at the Krupp plant. Wheels, frames, steering elements, and armored compartments for the engines and crew. Partial assembly was to be completed in Essen, but Allied bombings forced the final assembly to be moved elsewhere. On August 10, 1944, the Weapons Office again inspected the partially assembled Raumer S, this time in Hillersleben. Krupp promised to complete the machine in September. They did not fulfill the promise. On October 20, 1944, Krupp reported that the machine could not be finished by September 15 due to unspecified problems. The new deadline was the beginning of November. Tests were planned in Kummersdorf. Construction was finished in 1944. Tests began, but they did not have time to finish them. The war was coming to a close. The Allies were advancing from the west and the east. The strange steel giant remained on the test site. two firms created two monsters with a total weight of 180 tons. Both machines were supposed to turn the tide of the war by clearing a path through any minefield. But why did neither of them ever see the front? What happened during the tests? Summer of 1942. The Kummersdorf test site near Berlin. Alkut's three-wheeled monster is ready for testing. 50 tons of steel, 3 giant wheels, a double-armored bottom. A machine that was supposed to solve the problem of Soviet minefields. The engineers were confident it would work. The military wanted to see results. The very first run proved to be a catastrophe. Steering the machine turned out to be a nightmare. The driver turns the wheel, the worm shafts begin to rotate, the chains tighten and pull the rear wheel. But this whole system works slowly, with delay and inaccurately. 50 tons of weight create monstrous inertia. The machine does not obey. Turning begins late. The turning radius is enormous. Precise maneuvering is impossible. On the firm road of the test site, the VSK FZ 617 barely accelerates to 10 kilometers per hour. The 300 horsepower of the Maybach HL 120 try to move this mountain of metal. The specific power of 6 horsepower per ton is negligibly low. For comparison, the KV-1 tank had 11.5 horsepower per ton. The German sweeper is twice as weak in this regard. But the real hell began when moving on to soft ground. 3 wheels with shoes create pressure on the ground, but the weight distribution is uneven. The front 2 wheels bear the main load. On sand, on clay, on any loose soil, the wheels begin to sink. The shoes bury themselves, the engine roars at maximum RPM, and the machine stops, stuck dead. 50 tons of weight turn into a death sentence. German engineers tried to fix this. They changed the installation angle of the shoes, adjusted the chain tension, and improved the steering. Nothing helped. Fundamental design problems could not be solved by minor adjustments. And then there was the problem of combat use. A machine almost 3 meters high, more than 6 meters long, with a speed of 10 kilometers per hour. This is an ideal target for any anti-tank gun. A Soviet 45mm gun would destroy such a sweeper with the first shot at a distance of a kilometer. A 76mm divisional gun would pierce it through and through from 1.5 kilometers. The armor protects only against heavy machine guns. The double floor with a thickness of 40 plus 20 millimeters is designed for mine explosions, but the side armor is weak. The turret from the Panzer I was generally symbolic. 2 MG-34 machine guns will not help against infantry with anti-tank rifles. The German command looked at the test results and made a decision. The project is closed. The machine is good for nothing. Too slow, too clumsy, too vulnerable. On the Eastern Front, it would survive 10 minutes until the first hit from an anti-tank gun. The VSK FZ 617 was left at the Kummersdorf test site. They simply abandoned it, not even destroying it during the retreat. April 1945. The Red Army is advancing on Berlin. Soviet troops capture the Kummersdorf test site. Among the trophy equipment, they discover a strange 3-wheeled machine. Registration number NK101. What this is not clear. There is no documentation. In their haste, the Germans did not have time to destroy anything properly. The trophy is sent to the USSR. First through Dresden, then further east. The machine is delivered to the tank test site in Kubinka near Moscow. Soviet specialists are curious about what kind of design this is. Maybe the Germans came up with something valuable. Testing began in 1947. On July 31, 1947, a final report was compiled. Soviet engineers tested the machine in all modes, checked the driving qualities, and measured the clearing width. They conducted a blast test on a real anti-tank mine. The clearing width, according to documents, was 3,170 millimeters. It sounds good, more than 3 meters, but the real effective strip was completely different. The 3 wheels leave 3 narrow tracks. Each track is about half a meter wide. Between the tracks, there remain uncleared strips of ground more than a meter wide each. In total, the effective width of the cleared strip is only 1,900 millimeters, less than 2 meters. This means that between the wheels, huge sections with mines remain. A tank following the sweeper might blow up on a mine in the interval between the wheel tracks. Infantry are at the same risk. The passage is not a solid one, but in the form of 3 narrow paths. Complete nonsense for practical application. Then they conducted the most important test, a blast on a real anti-tank mine. The VSKFZ 617 was towed behind a tank, brought to a mine, and the tow line was unhooked. The machine drove under its own power over the anti-tank mine. Explosion, a column of earth and smoke. The machine jumped, and the wheel hit back into the crater with a crash. The shoes held up. Their attachment system is indeed strong. The double bottom held. There was no armor penetration, but the crew inside received a severe concussion. The mechanic and the driver were in shock. The shock wave passed through the hull. Despite a meter of ground clearance and a double bottom, the energy of the explosion still reached the people. After such an explosion, the crew would not be able to continue working. Medical help would be needed. And that is just one mine. In a minefield, there are hundreds. They checked the armor by firing at it. A 45mm shell pierced the armor easily. A 76mm shell went straight through the machine. The armor only protects against large-caliber machine guns. Against any anti-tank artillery, it is defenseless. Soviet specialists gave their verdict. The design is outdated, the machine is useless. Large mass, low specific power, poor maneuverability, weak armor despite huge dimensions. The effective clearing width is insufficient. Up to 40% of the total strip remains uncleared. The speed of movement is negligible. The cross-country capability is disgusting. The machine is of no interest to the Soviet Army. It is a dead-end branch of development, an example of how not to make minesweepers. The VSKFZ 617 was sent to the Museum of Armored Vehicles in Kubinka. Let it stand as an exhibit of the Third Reich's engineering madness. But if the 50-ton VSKFZ 617 turned out to be so worthless, then what did the 130-ton monster from Krupp show in tests? The Americans who captured it conducted their own inspection. Krupp's tests by the Germans continued until the very end of the war. Constant adjustments, and nothing works as it should. On April 17, 1945, the 30th Infantry Division of the U.S. Army captures the artillery test site in Hillersleben. Among the trophy equipment, they discover a monster, 130 tons of steel, 2 sections connected by a hinge, 4 steel wheels higher than a human. What this is, the Americans do not understand. The strange capture quickly got into the press. The Associated Press Agency released an article under the headline, "Strange New Weapon Found on German Test Site." Journalists described the machine as undoubtedly the largest land construction that could appear in this war. The purpose of the machine at that moment was known to no one. It looks like something between a tractor and a roller. No German documents. The crew ran away. The Americans began their study. The conclusions turned out to be the same as those of the Germans. Everything was the same as with the VSKFZ 617, only worse. Steering was an even greater nightmare due to the articulated construction. Two sections connected by a hinge require the coordination of movement for both halves. Drivers in each section must work synchronously. The slightest lack of synchronization and the machine turns sideways. In turns, the hinge bends at an angle of up to 44 degrees. This creates enormous loads on the connection. Precise maneuvering in combat conditions is impossible. The road speed of 25 kilometers per hour was theoretical. In practice, it was even slower. On rough terrain, 8 kilometers per hour. That is slower than a pedestrian. 720 horsepower from two Maybach HL90 engines try to move 130 tons. The specific power is 5.5 horsepower per ton. Even worse than for the VSKFZ 617. The machine gets stuck even more often due to the monstrous weight of 130 tons on four wheels. The pressure on the ground is enormous. On any soft soil, the wheels sink up to the shoes, the machine buries itself, and the engines roar at maximum. Nothing helps. Pulling out a stuck Raumer S is only possible with other tractors, but what tractor will pull 130 tons? The clearing width is 3.27 meters according to the width of the front track. It sounds impressive, but the wheels are narrow, 53 centimeters each. Four wheels leave four narrow strips. Between the strips, huge uncleared gaps remain. The rear track is narrower than the front at 2.6 meters. This means the rear wheels do not pass in the track of the front ones. Between the tracks remains the minefield. The American report on the trophies even expressed doubt that this machine was actually intended for mine clearing. Wheels too narrow for such a task, insufficient width of the cleared strip, disgusting cross-country capability, negligible speed. Maybe it is a transport tractor or a test stand. It is not clear. The Americans did not even spend time on full-scale tests. Why? The machine is obviously useless. Not for mine clearing, not for transport, not for anything else. 130 tons of scrap metal. The post-war fate was simple. The Krupp Raumer S was disassembled into two sections for transport. It was towed to a collection point for trophy equipment. They planned to send it to American Depot 044 near Paris for further testing. But the machine never reached Paris. The trail is lost. If you like this story about military monsters that never fired a shot, give a like and subscribe to the channel. We have many more insane stories of failed military technology.